Hi, all. I'm here today to discuss Midnight, which is a data protection-based dApp development chain built on Polkadot SDK. My goal is to share what we're building at Midnight, as well as some interesting ways we're using Polkadot SDK across Midnight and IOG. About me, my name is Justin, and I'm one of the developers on the Node team at Midnight. And I've worked on Polkadot SDK-based projects for about 3 years. So I'll structure this talk as follows. I'll briefly describe Midnight at a high level. I'll go into how we're using Polkadot SDK for some specific use cases in Midnight. I'll go through the future of Midnight, give a word on where we see ourselves fitting into the Substrate ecosystem before closing it out. So we can talk about what Midnight is in terms of some of its core features, data protection, the assets that live on Midnight, and the fact that Midnight is a partner chain to Cardano. To talk about data protection, this is a notion that works kind of like privacy that you might find in other privacy-preserving blockchains, though for us, we slap on an additional feature of selective disclosure, which is a compliance and regulatory feature. And I'll get into what that looks like in a bit. So we provide data protection over asset transactions as well as contract state. And powering all this, we have an unshielded token, Night, as well as a shielded token called Dust. And the last fact to know about Midnight is that it's the first Cardano partner chain. And a partner chain here means a share of security and utility between a given chain and Cardano. So I'll talk about Midnight's main feature, which is data protection. Midnight delivers data protection features through verifying ZK snarks over some particular executions. The proofs in question show that some execution was performed according to Midnight's own protocol rules or a given contract that's deployed on Midnight. These proofs can also operate on private state, and this is what gives us the data protection properties of Midnight. To support all this, Midnight provides the language features for developers to define those rules and the tooling to generate proofs of execution of those rules locally. To talk about proving here quickly, Midnight utilizes the Halo 2 proof system as its ZK snark primitive, and this is over the BLS 12381 curve. And we use KZG for polynomial commitments. These were chosen for reasons of performance, but I can't get into the specific thinking there without going out of my depth. But what we can talk about are some of the things that Midnight provides data protection over, and that's its two of its core features, asset transactions and data protection contracts. For asset transactions, we primarily provide atomic swaps. Here you can think of atomic swaps as a type of transaction where parties exchange a number of offers between one another in a privacy-preserving manner, and in a way which follows the rules of Midnight's protocol. IOG's done research on a specific transaction scheme here, which is called ZSwap. There's a body of research around this, and we've also named the protocol that we use for this accordingly. Roughly, you can think about privacy here as being over some common fields that you might see in a transaction in any typical blockchain system. So sender, recipient, and transfer amount. Note that this is all subject to opt-in selective disclosure. And we also provide a notion of data protection to smart contracts. This is mainly in the form of a provable private state, where contracts can prove properties about some off-chain state while also being able to interact with the on-chain state in the same way that's available to typical smart contracts. So developers have a bit of an expanded tool belt where they can interact with both type of states, send state back and forth, prove that it's correct, and And yeah, developers define these interactions or constraints in our language compact, which is inspired by TypeScript. And just to talk quickly about why Midnight is a bit different from the rest when we talk about privacy or data protection. I'll start with developer experience. So Midnight's compact language and its TypeScript tooling are arguably very simple to grasp. And that's because they abstract the circuit development away completely behind a language that looks more or less like TypeScript and just leaves you with the primitives that you need to reason about state privately. So a lot of the DSL type language or proof system primitives that you might see in other systems where you're developing similar, you don't have to work with those. It's closer to typical app or program development. And another thing is that Midnight will integrate contract state recursion. This is similar to proof recursion, if you've heard of this term in the ZK proof world, where in ZK circuits, a circuit is able to take a compatible circuit is able to take as input another circuit's proof and efficiently verify that proof within its own proving. And so we want to do the same thing with contracts, where our contracts can represent one or more ZK circuits, and they would output proofs, and other contracts would be able to take as input those contracts' proofs. And so this is another level of interoperability, which is pretty interesting because these contracts could reason about one another's states privately without necessarily knowing all the details of the states that got them to the proof. And then finally, Midnight leverages upgradability features of Substrate, which is just an out-of-the-box differentiator. I don't think I need to go into depth about forkless upgrades or anything like this. We're probably all familiar. So if we talk about Midnight, we have to talk about partner chains, because Midnight is the first Cardano partner chain. So roughly, partner chains are L1 chains that utilize the security of Cardano. Specifically, partner chains tap into the validator set of Cardano. From a development standpoint, partner chains are enabled by a boilerplate substrate node as a starting point. You can think of it as similarly to the substrate node template, though this one just has a few palettes and client-side modules that allow it to communicate with the Cardano network. Components within this example allow developers to bootstrap their network, leveraging Cardano stake pool operators, which are a type of block-producing node, which receives stake delegation. So you can imagine this is the example node over here. Palettes and client-side components not pictured. And it's able to communicate to Cardano via two components which must be run for any node operator who's running a partner chain. The first is an indexer, and then the second is an actual Cardano node. This component retrieves some stake distribution data from the indexer, and it uses that information to inform the validator set selection. So I'll discuss some interesting ways we've been able to adapt a privacy protocol to use Substrate. So Midnight's core protocol, which I described earlier, is implemented in a component I'll refer to as the ledger. Can you guys hear me? OK, thanks. Sorry. Yeah, right. So the ledger contains all the components I've described previously, the assets, their transactions, contracts and all their states, the ZK verification, and all the state that's required for this component. And the ledger presents some interesting challenges to integrating to a typical Substrate environment for a number of reasons. Namely, it's native Rust by design. It's subject to its own versioning. And in fact, it's subject to multiple types of upgrades, which don't quite fit with the typical Substrate runtime upgrade paradigm. And finally, for now, it results in very large states. And those are kind of difficult to work with in a typical Substrate runtime. So if you can imagine, the challenge here is we want to have some sort of palette which receives transactions that are specific to this ledger, and it can send them down to this ledger in order to perform state transitions, essentially. So surprise, surprise, the current thinking for this and the current implementation relies on this model where we have host functions which implement the ledger. So in this model, we maintain some storage items in the palette itself, and those storage items represent the current state of the ledger at any point in time. Transactions specific to the Midnight ledger are received in the palette, and we just send them down through the host function to do proof verification and state transition, and then a new state is returned. And then we have the new updated state for the ledger. A few interesting things. I mentioned that we deal with large states in the current form of the ledger. And these are kind of hard to work with in a typical WASM environment. So one interesting API that's available to host functions is one that allows you to update storage of the node locally. So host functions have exposed to them substrate externalities, which expose a number of substrate storage. Hello? And these call the storage natively, and this gets around any memory allocation difficulties of sending large states through the runtime or anything like this. The other piece to the ledger is its own versioning schemes, and in particular, a requirement around upgrades, which I'll actually mention in the next slide. But we have to think very carefully about how we version the ledger. And one thing that's interesting about host functions is that they come with versions on any given host function. So I can define host functions for my node, and I can introduce incremented versions of that host function. And for us, concretely, we simply wrap future versions of the ledger within incremented host functions. Sorry, is it echoing?
No, something's wrong.
Oh. Testing. OK. So for every given version of the ledger, we wrap in a versioned host function. And as the chain grows and as the ledger progresses, we can maintain full compatibility with all versions, no matter how large the chain grows and how many upgrades we go through, et cetera. Yeah, so host functions feature some subtle features whose uses may not be so obvious, but in our case, they essentially enabled our entire use case. So we thought it was interesting. It might be interesting to talk about. Related to host functions managing the ledger, we have an interesting requirement, and that is to enable governance and upgrades by block producers of the node, in that people who actually produce blocks are granted a vote in the protocol. In some sense, we want to support a hard fork-like process where adoption of a client is observed per block. But we also want to enable the built-in runtime upgrade functionality, because it doesn't make sense to throw the baby out with the bathwater. So we ended up with a process where updates to a new client image, where that image features a spec version bump, automatically trigger a voting process for the new runtime. Block producers who observe this new version send votes through an inherent transaction, and when a configurable threshold of votes in favor of a given spec version is met, the runtime upgrade is automatically attempted. And one thing that's interesting about this process is that we can manage our ledger upgrades in this way. We can release a node version that has a bumped host function, and at some point in the future, a runtime which points to the newly exposed host function is attached to a node version. And clients who adopt that version will signal their adoption when they're ready, and then once the threshold is reached on chain, then we'll autonomously trigger the runtime upgrade, which enacts the new ledger version. We considered some other solutions to achieve the overall goal of governance by block producers. Like you can imagine some custom origin or collective-based solution here. But this mode actually fits a bit more closely with how governance messages from Cardano will arrive to partner chains in a general sense. And it also weights more heavily to voters based on the blocks that they actually produced. To talk briefly about the current state and future state of Midnight, we just finished a DevNet phase, and I would describe our current phase as testnet. In our DevNet, we delivered initial implementations of data protection and smart contracts. In our testnet, we've onboarded block producers through the full permissionless process, where they register via Cardano and onboard in a typical way that you would, in a way that's typical for Substrate. After that, we've altered from a Planck-based proof system to Halo 2. We introduced an unshielded resource, and we've implemented the hard fork process, which I described in a previous slide. To try to finish up here, a few interesting features that we would like to implement in the future include ZK recursion. I described a feature where contracts would be able to verify proofs output by other contracts. So we'd like to include that, but also expand this to our entire chain, where we would prove the entire state of Midnight from genesis to the head and output a small constant-sized proof so that somebody else in another decentralized environment can verify that ZK proof and be convinced that the entire state of Midnight and history of Midnight is correct at any given point. And that would tie into the next one, which is a trustless bridge. We're interested in a ZK bridge. So we might involve something like a proof of our state, but this is pretty early in design, and we're not settled on a solution yet. We're interested in implementing a custom consensus. We're kind of interested in some criterion such as high throughput and a few other things. And there's a few other items on this roadmap. And so to talk about the ecosystem briefly, we're pretty interested in contributing back to the ecosystem. We're not very interested, it's not very interesting for us to just use Substrate and not give anything back in some sense. So we're trying to start track PRs that we've created across our team, Midnight, and also the partner chains team at IOG, as a way to start discussing and collaborating around this. We'd like to get better at this and potentially find other ways to contribute back. So if anybody has any ideas, I'm totally open to them. And that's all I have. So if you're at all interested in developing private smart contracts, if you're at all interested in working with ZK without worrying too much about ZK internals, I would advise you to check out our docs. That's included in the QR code here. There's also plenty of material about our protocol, white papers included, and some research around our atomic swaps, and the state management for our contracts are also linked. We also have a Discord with mods and DevRel engineers who are on hand to answer any questions, chat, or talk about Midnight in general. So feel free to join in and join the conversation. So that's all I have. We could do questions or...
Yeah, fascinating stuff. Thank you, Justin. Do we have any questions for... Yeah, let's go.
Hello?
Hey.
Good. About the selective disclosure and the regulatory compliance, could you touch a bit into it, how that works?
Yeah. I don't have much I can say on that, and it's mainly because I'm not involved with that team. I'm aware that users of our chain have some notion of a viewing key that they can use to reveal states that belong to them. So I think the interactions would look something like this, that they're able to reveal states that they own. And you can imagine this might be over assets that they've transacted with. Compliance and regulatory and regulation in general are kind of a concern for privacy-focused chains. And so we're interested in ways that we can provide disclosure when necessary.
So I guess you would give this key like to a government or some entity that needs special access.
Potentially, yeah. Yeah, these are examples of entities who might be interested.
Cool, thanks.
Yeah.
Great question. Interesting topic. There's a guy there. Yep.
Hi. So I had this question. So in the privacy preserving manner for validating the off-chain state on the contracts level, so I believe like you are doing it with Solidity, the contracts part, right?
No, we have a custom language called Compact.
Yeah. So, but how is it compilable? So if there's, at the palette level, can we do off-chain state verification at the palette level? Or it has to be contracts?
In a sense, yeah. So the model might be a little bit different. And I probably could have included a diagram here, but I filled up a bit of my diagram space. So the way the flow works is that a developer compiles their program, and after that program is deployed, they're able to generate proofs of execution of that contract. And those proofs are sent along with some transaction data to the chain. And at that point, we receive it in a pallet. So in some sense, we interact with some representation of that contract. But I think it's at a different point than maybe what you're thinking.
Yeah, but the verification, does it happen at the palette level or at the contract environment inside the contract environment?
Yeah. So if we're talking about ZK proof verification, this is happening on the native side. So a transaction is received. It's this sort of ledger transaction, and we send it down to the native side via a host function. And then it interacts with a library that's developed by one of our teams. And that library is responsible for doing the ZK proof verification, the state transition, and a few other things that I'm probably not privy to. But the verification happens there. And then we receive a new state, and we bring it back into the palette.
Lastly, currently the apps, or how are the people storing these states? Do they have like a new wallet app, or is it through the app, like the app itself stores into the user's browsers? The state, where is it stored, and how is it data like available for that state?
Yeah. So it's up to the developers. I might not be too up to date with design of privacy preserving apps. So a developer is able to work with off-chain state. And all that matters is that they provide correct proofs of that off-chain state according to the contract. So as long as that fulfills all those rules, then it's all okay. And it's up to them how that data is to be stored. Yeah.
Thank you. Nice.
Yeah, hi, sorry. So my question was that in all these ZK related systems, the proving time or proof generation takes a lot of time. And the proof generation itself is very resource intensive. So like what are you planning to basically decentralize the proving part? Like do you have separate provers, or those are the part of the validators itself?
Yep.
Yeah.
So we expect proving to be done locally for the most part. I agree that proof generation is something that takes a very long amount of time. It's also a notable bottleneck for us at this early stage. I don't keep up to date too closely with what our cryptography and research teams are doing. They do a lot of experimentation with the proving. Like for example, we recently switched from Pluto Eris to BLS 12381. And that was strictly for performance reasons, for things like speeding up proving. But we're pretty optimistic about reduced proving times as research in the area improves, and we see different teams getting proving down to like half a second, even for similar protocols, like privacy protocols are doing like I think sub-second. I'm fairly certain. So that's a lot of hope for us.
So the proof generation, does it take place within the validators itself, or there's a separate infra for it?
We haven't really defined a particular place it should be happening. We just recommend that proof generation happens locally for now. So for the dApp developer, that would be wherever their data is. We don't recommend, with our stance on privacy, we don't recommend people outsource proving at this current point. We don't have any design where we work with TEEs or do any interesting MPC to split the data so that we could share it, we could, avoid any issues of privacy or disclosure of anything that shouldn't be disclosed. And I'm not aware that we're going to do any of those in the future. No.
Thanks.
Yep.
Anybody else? No, super interesting topic, and it's nice to get privacy happening on Substrate again. Justin, you didn't tell us when mainnet. Well,
When mainnet?
it was right there.
Yeah, we don't have a date for mainnet yet.
Oh, good.
Yeah,
It's okay.
yeah, soonish.
Buddy, thank you very much for coming on. It's super awesome. Thank you.